Hello, how are you? I'm going to do an example of a Bayesian network, and I probably am going to give you a homework involving this also. Now, what this is we have certain information, both some probabilities and some conditional probabilities. We have 8 different events that we're talking about. And in this particular case, I said 8, I meant 6 again. We have 6 events arranged in this particular order. What this graph says is E is dependent on A and S. O is dependent on E. R is dependent on E. T is dependent on O and R. Also, it says that A and S are independent of one another, and O and R are independent of one another. They're not related. Now, in our example, the names, the variables, the first one at the top will be age. And in our particular sample, we're going to have 50% young, 30% adult, and 20% old. And then we'll have sex. We'll have 60% male and 40% female. The next box is the conditional probabilities. Read this as there are 2 possibilities for enthusiasm, high or uninterested. The probability of high, given that S equals M and A equals Y, is 0.75, as you can see right here. And of course, the probability of U would just be the 1 minus that. So there are 6 possibilities, 3 here and 2 here. So that's 3 times 2. And I've got the probability of high in each case and the probability of uninterested in each case. Next, the probability that you're either employed outside yourself or you're self-employed is dependent on whether you have high or uninterested enthusiasm. And again, I've got the conditional probabilities. The probability of E given H, the probability of E given U. The same thing is over here, whether you're in a large area or a small area. And then finally, we have the transportation, which is dependent on both of these. So again, I have 4 cases. So what I want to compute is, what is the chance you use a train if your age is young and your sex is male? Now, the train is dependent on the O and the R. The O and the R is dependent on enthusiasm. The enthusiasm is dependent on the age and the sex. So we have to unwind this in some sense. And here's where I'm going to start showing you that you might want a computer to do this. I can give you the probability that E equals, pardon me, I'm going to start down here. I want the probability that T is a train given age is Y and sex equals M. Well, that's the probability that T is a train given that E and SM times the probability of E and SM plus the probability of E and B and E and B times B and so on. And in each case, it's these pots. What this is the law of the entire law, the total law of probability that I showed you in the last of the videos. I took the 4 possible cases and then the probability of train in each of those cases. Now it gets a little worse. Now I have to compute the probability of E and SM and then the probability of E and B, and this. Remember, I have these four. Those are the conditional probabilities. So if I'm going to do E and SM, E, the two items I'm working with, the occupation and the residential, are independent of one another. So the probability of both of them is simply the product of the probability of each of them. So probability E of S and M is the probability of E times the probability of SM. Now I have to do this particular computation 4 times for these 4 different probabilities. I'll just begin going for this one. Well, the probability of E, see, E is up here, it's employed. It depends on H and U. So I have the probability of E given H times the probability of H plus the probability of E given U times the probability of U times, that's this times here, the probability of small given H times the probability of H plus the probability of small given U times the probability of U. Well, again, I have the conditional probabilities. Now I need the probabilities of H and U. Well, now it gets more complicated. The probability of H depends on age and sex. So we want the probability of H, given that we know, let's see, we know that the age is young and the sex is M. So we know that I'm a little concerned here. I think I skipped an item here. No, I didn't. Given that the age is young and the sex is male. Well, we have that. And but now also that's not enough. That just gives us that particular well, I think that is enough. It just gives us the probability of H in that particular case. And I think that gets it for us. So look at what you got to do. You're also going to have to compute the probability of U given age equals Y and sex equals M. Now, is that enough? Well, let's see. We need the total probability of H here. We have this part. It should be enough because we have the evidence that we have Y and M. So that should give us what our H is in this particular case. So now we have everything we need, and we just unwind this backwards, and we get an answer. So where is the advantage of having it in the network? The advantage is that you have all these things together, and you can look at the picture and see what depends on what. I built this out of this information that came from the website, the values of A, S, E, O, R, and T, the probabilities for A and S, and then the conditional probabilities for everything else. And I put those all on that graph for you, and I just went through the details. So what's the point here? The point is that our probability in these Bayesian networks gives us a lot of information, but boy, is it computationally complicated. We only have 6 nodes. Imagine if we had 50. That's where you would want the program to take over and do it for you. So that's what I wanted to say about Bayesian networks. This is actually the second example I've given you because there was another example on the last video. And that's the one I believe I'm going to use for the homework. So good luck and see you later. Bye now.